neat stuff today. The word torpedo will be used, as in NATO torpedo. Okay? But before we go on to what we're going to cover today, let's, as usual, look at last week's homework a little bit, some of the tougher problems. Okay? I'll do 2 or 3 of them. Okay? Okay, one of the homework problems asks you to evaluate this nightmare, the cosine of 42 degrees, cosine of 18 minus sine of 42 times sine of 18. Well, the idea is you're supposed to look and see which of the things that we learned last time and that it looks like. Okay, well, looking at this, I see that it looks like I see a cosine and a cosine minus a sine and a sine. And it looks like the identity for the cosine of the sum, SUM sum of 2 angles. Okay, so that's the one I'll use here. Well, what are the 2 angles? They happen to be, in this case, for the formula, alpha will be 42 and beta will be 18. So it'll be the cosine, recognizing the right identity, of 42 plus 18. Okay, well, that's not too tough. 42 plus 18 happens to be 60 degrees. Now, in this case, they asked me to evaluate it. Okay, so I have to actually evaluate the cosine of 60. You can either use your calculator, or if you're a hardcore, you can remember the 30, 60, 90 triangle ratios and know that the cosine of 60 is 0.5. So when they ask you to evaluate it, that means you have to actually give the answer. Okay, so our answer in this case is 0.5. Okay, another one similar to this. Now this time they don't ask to evaluate it, they ask us to simplify it. Okay, well, let's see. I've got to decide what identity this reminds me of. Okay, now if you look at all the ones we learned last time, the one that's going to fit in here with cosine alpha, cosine beta, plus, not all of them have plus, sine alpha, sine beta, it's going to be the difference of 2 angles, or the cosine difference of 2 angles identity. Now you have to go over all your identities to recognize that. But that's the idea, and it's trying to get you to go over all your identities, okay? Okay, so let's see. So in this case, alpha is going to be 41, and beta is going to be 17, okay? So it'll end up putting it into the formula. Simply, it'll be the cosine of 41 minus 17, which is the cosine of, hi mom, 24 degrees, okay? Now in this case, they only asked me to simplify it, so I've done it. I've simplified it. It's a cosine of 24 degrees. It looks way the heck better than all this garbage, that's for sure. Okay? So that's all they're asking you to do in the homework. Okay, let's do one more. This is the hardest one. Okay? They're going to give you the sine of an angle called U, and they're going to give you the sine of an angle called V, and they don't even want to know about the sine. They want you to evaluate the tangent of U minus V. Now, we can't get the tangent of something just knowing the sines. Okay, we have to know the sine and the cosine, remembering that the tangent is the sine over the cosine. So we're going to have to figure out the cosines first. Okay? Well, we know the sine of this angle U is 5/13. Okay? Well, remember, once you've given the sine of something, you can figure out the cosine of something. How do you do that? Well, you use what's called the Pythagorean identity. Pythagorean identity says that sine squared plus cosine squared equals 1. Okay, well, cosine is what we want to know, so it's sine squared plus question mark squared equals 1. Now let's solve for our variable there, for our question mark. I'm going to subtract sine squared from both sides of this equation. Okay, I put in the 5/13 squared, and I'll subtract it from both sides. Okay, now let's see what we get here. 5/13 squared is 25 1/69. Okay, now if I get a common denominator, 1, known downtown as 169 1/69, and subtract 25 1/69, I'm going to get a real sweet number. 169 minus 25 is 144. So and 144 1/69 is squared of what I want. Okay, so apparently what the cosine of U, or what I want, is 12/13. Where did I come up with that? Well, I took the square root of both sides. Okay, so I know the cosine of U. Let's do the same thing with the V. Knowing the sine of V, I got to figure out the cosine of V. Once again, use a Pythagorean identity. Sine squared plus question mark squared is 1, or plus cosine squared, which is what we want. Okay, putting in the sine, which they told me, 12/13, there it goes. Okay? I'm going to subtract that 12/13 squared from both sides. As long as I do it to both sides, it's okay. Okay? Multiply it out, get 144 1/69. Okay, now I've got to get a common denominator, as I did before. 1 is 169 1/69. And I'll subtract it out. And sweet as can be, it comes out to a nice number, of course, 25 1/69. It wouldn't always do that, but it does. And I can, as I did before, take the square root of both sides, and I'll know that the cosine of v is 5/13. Now remember what I'm trying to find here, okay? I'm trying to find the tan of something. So I know the sine of it, I know the cosine of u. Now I got to figure out the tan of u, because I'm going to need the tan to do this theorem, okay? Well, the tan is the sine over the cosine, so it'll be 5/13 over 12/13. Okay, well, let's multiply top and bottom by 13 like you do a complex fraction, and the tan of u will be 5/12. Okay, so I'm halfway home. The sine of v, I know, is 12/13, and I just figured out the cosine of v, so I can figure out the tan of v, okay, by doing sine over cosine, right? And that'll be, let's see, 12/13 over 5/13. I'm going to multiply top and bottom by 13, which I'm allowed to do with complex fractions, and get 12/5. So now I know the tan of u and the tan of v. What I want to figure out is the tan of u minus v. Okay? And there's a theorem for that we learned last time. Where is it? Where is it? Come, oh, there it is. Okay, we want the tan of an angle minus another angle is this nightmare. Okay? Probably don't want to memorize it, just know when to use it. Okay? So let's bring it in and fill in these two numbers that we just figured out, the tan of u and the tan of v. If I fill those in to my identity here, there's the 1, there's the two numbers multiplied, and just basically I'm just going to put it in the calculator because I'm too lazy. I note that 5/12 times 12/5 is 1. So this bottom is going to end up being 1 plus 1. Okay, but if I put all that in the calculator, I'm going to get either, if you do it by hand, negative 1/19 1/20, or if you put it in the calculator, I'll get exactly or close to 0.991. And they asked you to evaluate it, so that will be your answer. Okay, that's what we'll use. So that was a lot, okay, and you had to know all your identities to figure out which one to do. Okay, so there's our homework review. Now, we're going to do some stuff on the law of sines. Before we go on, I want to talk about what we've learned. We're going to be solving sides of triangles. Okay, let's review. Typically people say, well, I already know how to solve all the sides of triangles. Why do I need anything more? Well, let's review what we already know first. Okay? How to solve what we've solved so far. Well, we know how to solve using the Pythagorean theorem. What are we given with the Pythagorean theorem? We're given two sides. Okay? For instance, this isn't that hard. I'm looking for the hypotenuse. Okay? We know that in this case, a squared plus b squared equals c squared, or 1 squared plus 2 squared equals what I want, squared. Okay? Figuring it out, let's see. 5 must be the hypotenuse squared. Well, gee, what's the hypotenuse going to be then? Well, whatever number multiplied is 5, or square root of 5. Okay, it's going to be some number between 2 and 2 point blah, 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 some number between 2 and 3, which your calculator could figure out for you. Okay, so that's how we can solve given two sides of a right triangle. Now, what if we want to find a leg? Last time we wanted to find the hypotenuse. What if we want to find a leg? Well, we're going to use, in this case, we'll say that's b that we want to find. Well, we're going to solve for it, so we'll subtract a squared from both sides, and this time, instead of adding, we'll subtract. Okay, c squared, the hypotenuse being 2, and a, the leg being 1. Okay, so it's the same deal, except we're going to subtract 4 minus 1. So what we want squared is 3. So what is the actual length of this bad boy? Well, it's the square root of 3, which there is a number that's the square root of 3. What is it? It's about 1.732, so it's not like some mystery number or something. So, and that looks like a good estimate of what that is. Okay, so that's something we've already learned to solve. What about, we've been given two sides to find the other side. What about when I ask you to I only give you one side, but I give you one angle. Okay, remember, well, that's where we really used trigonometry. Okay, we had a problem where we wanted to find the volcano height as x there. Okay, well, I'm going to give you an angle, as I promised, and I'm going to give you a side. Okay, now we can't use a Pythagorean theorem because we need two sides. What did we do for this one? Here's where we used trigonometry. I recognized x being the opposite leg and the 4132 being the adjacent leg, and I recognized that the tangent is appropriate here. So x over 4132 was the tangent of this angle. This is nothing new. And I took the tangent using my calculator, got 0.68132. Now I'm going to multiply both sides to solve for x by 4132, and I'm going to get an answer. Okay? So apparently we can get any of the sides given one angle and one side. Okay, this is all old news, right? What if I wanted to find an angle? Now, last time I was trying to find a side. I want to find an angle, and I'm giving you two sides. Now, remember this one? I'm going to give you this side, and you're supposed to figure out what angle. Well, in this example, I'm trying to find x degrees. In this case, not always the case, this will be the opposite leg, and this will be the adjacent leg, and I smell tangent. Okay? So 30 over 125, the opposite and adjacent is going to be the tangent. 30 over 125 is the tangent of this angle. It's not the angle, it's the tangent of the angle. Okay? And 30 over 125, you calculator guys can figure out, is 0.24. Now, so what I do is take the untangent, or the inverse tangent of 0.24 using my inverse tangent button, and I get that x is 13-something degrees. Okay, so I can do that too. We already know all that stuff. Okay? And we can fire the cannon. Well, that was all with right triangles. What do we do with non-right triangles, known downtown on Friday nights as oblique triangles? What do we do? Well, tune in. Okay? First thing we're going to do is make them right triangles. Okay? But let's define this triangle, and I'll talk about it. I'm going to talk, if I talk about each of the corners or the angles being A, B, and C, remember that every time I use a capital letter from now on, I'm talking about an angle. Okay? As opposed to every time I use a small letter, for instance, this, come on in, come here, don't be shy. A small letter is side A. Why did I call that side A? Because a side is always going to be, I just happen to call him A, the side that is opposite the angle of the same letter. Okay? Which means side lower c, little c, I know it's a little letter because it's a side, will be opposite the angle C, and B will be opposite his in this triangle. Okay? So just get used to that, the difference between capital letters and small letters. Okay? Basically, it's the difference between angles and sides. And we have six things to find. That's called solving a triangle. Okay? Well, what are we going to do here? Well, we don't have a right triangle. We can't use those trigonometry identities, and we can't use the Pythagorean theorem. Well, I'm going to get fancy here. Don't worry, you won't ever have to do this, but I'm going to do it for you so you don't think I pulled this theorem out of my hat. Okay, I'm going to bring down the height of this, or the altitude of this triangle. Okay, and I want you to consider, isn't it true that h over a is the sine of b? Let's see, h over a. The opposite over the hypotenuse, there's angle b, is the sine of b. Yeah, that's true. Okay? Well, just for a laugh, let's solve for this h, this new guy. I'm going to multiply both sides by a, and apparently h will be a sine b. Now don't just hang tough. I'll show you where I'm going with this. Okay? Now, what about the sine of a, this angle a over here? Couldn't you say that that's opposite of a over the hypotenuse? So it's h over b is the sine of a. Now I'm talking about the sine of a, not the sine of b. Okay, and once again, I'm going to solve for h by multiplying both sides by b. Crossing out, h will be b sine of a, b sine of a. Okay, so this h, which is the same as this h, can really be two things. Okay, in any triangle. Okay, well, remember these two are the same animal. If those two are the same, then these two are the same. This must be the same as that. Okay, well, we're starting to smell a theorem here. Okay, well, I'm going to get fancy here. You never have to do this, don't worry. And I'm going to divide both sides. I was just playing with this earlier. Divide both sides by the sine of angle A, sine of B. I did it to both sides, so it's fair. Okay, as long as you do it to both sides. Now I'm going to have some cancellation here, right? This is going to cancel, and these two are going to cancel. What am I going to be left with? A over sine of A, B over sine of B, right? So guess what? A over sine of A equals B over sine of B. We have a name for that called the law of sines. Now we're going to throw in C because we didn't use that one. We could have if we rotated the triangle. This is the law of sines. A side over the sine of the angle opposite it is equal to any of the sides over the sine of the angle opposite it. Hence the term law of sines. Okay, don't say law of sins. Okay, I hear people say that. Okay, well this is a wonderful theorem. Let me show you how we can use it. Okay, for instance, in this is not a right triangle. Okay, how could I find, I don't know, for instance, this side, angle B? Well, it's not a right triangle. I can't use a Pythagorean theorem or tangents or cosines or anything like that. What I can do is B, using the law of sines, a side over the sine of the angle opposite it is the same as, I found a matching pair here, 4.56 over the sine of 43. Why did I use 4.56? Because he's the side opposite A. It's really known downtown as A. You know, here's an equation I can solve. Okay, let's see. I need to solve for B, so I'm going to multiply both sides by sine of A, by sine of 57, and that'll cancel. Okay, and B will be all of this. Okay, which looks terrible, but if you put it in your calculator, I'm not going to take the time to calculate it. Use your calculator. I can get an answer. Son of a gun. It's not a right triangle, and I can get an answer. Just remembering that side over sine of opposite, side over sine of opposite, etc. Okay, cool as a mule. Okay, well, let's try and find something else. Okay, maybe I wanted to find this side. Okay, well, wait a minute. If I'm going to find that side, I kind of need to know this angle, right? Wait a minute. That C equals, as soon as I see capital C, I can figure out that angle knowing these two angles. Because I know all of the angles of a triangle add up to 180. Okay? So I can subtract the 43 and the 57 from 180, and angle C, hi Mom, will be 80 degrees. Well, now I can figure out C. Okay? C, the lowercase side C, over sine of 80 is, I got a matching pair, 4.56, which is A, over the sine of A, 43. And once again, this is not a hard calculation. Okay, I'll multiply both sides. What am I going to multiply by to solve for C? I'll multiply by sine of 80, cancel like a Jim Bob, and I'll get C equals all this garbage. Okay, that's not too bad. That's not too bad. Put it in your calculator and get yourself an answer. Okay, C is 6.58. Probably that's an estimate, but that's a close estimate, so that's okay. Okay, pretty neat, and it's not hard. Okay, the law of sines. Let's do another one more. Okay, let's see. I've got to find this angle. Now we're trying to find an angle. Well, let's see. I got a matching pair here. I see that the blue pair is matching. So I got 20 over the sine of A. The side over the sine of A is 15 over the sine of 30. Now I'm trying to find A, so let's solve for A, or sine of A at least. I'm going to multiply both sides by sine of 30. Okay, cancel that out. How's that going to help me? That's not going to help me. I'm going to multiply both sides by sine of A. How about that? Get him on the other side. Cancel that out. Now who's keeping sine of A from being alone? This troublemaker 15. Let's divide by him. Okay, cancel him. Now the sine of A equals all this garbage, which I can put into a calculator. Okay, so the sine of A, all that stuff, is 0.6667. I promise you if you put it into your calculator. Okay, but I don't want to know the sine of A. I want to know A. Remember your calculator, your old buddy? If you know the sine of an angle, you can find the angle by the inverse sine button. Okay, well let's take the inverse sine of 0.667, and we get that A is 42 degrees. So you can do the law of sines to find an angle as well. Okay? Do another one. We know that that's 42. We just figured out it's 42. Now, how's that going to help me? If I want to find C in this example, well, it's a good thing that I found that that angle's 42, because now I can find angle C, because I need the angle that matches with it, using your sum of the angles of a triangle is 180. 180 minus 42 in the 30 is going to be 108. Oh, that's good. That's good that I know that. Okay, so C over the sine of 108, we're using the law of sines here, is the same as any matching pair. I used 15 and 30. Could I have used 20 and 42? I certainly could have. Okay, I just arbitrarily picked it. Okay, let's solve it, multiplying by sine of 108 and canceling, and C will be all this garbage, which putting into the calculator is 28.5. Don't forget, you're going to need to know the sum of the angles of a triangle is 180. You needed to know that to do that problem. Okay? Let's do one last problem, and I mean it this time. Okay? Using the law of sines. Let's see. What do we want to figure out? We want to figure out this one. This is an angle. Okay? Huh! How are we going to figure out that angle? Well, I know the other two angles, so I'll subtract from 180, and I'll get that he's 121. Okay, well, now I'm on fire. Okay, now I can figure out, if I know that that angle's 121, I can go, let's see, C, I'm trying to figure out C, over the sine of 21, and I can pick whatever matching pair. I'm going to go 24 over the sine of 28. As long as you have a matching pair, you're golden. Okay, it's very similar. Solving for C, I get an answer of 13.97. It's not hard. Very similar. Okay? And you don't need right triangles. Okay? Now, knowing all these things, let's find our last thing. When I say solve for a triangle, you'll always be finding 6 things. 3 angles and 3 sides. Okay, the only thing we don't know now is the side A. It'll be A over the sine of 121 equals, now which matching pair do you want to use? Really doesn't matter, as long as you have a matching pair. Okay, we'll use the 24 and the 38. Solving for A, canceling. Okay, we're going to get all this stuff, which that's what you have a calculator for. Okay, and A is 33.41. Okay, so it's not that hard. So at this point, what I want you to do is try solving a bunch of triangles. Remember, that's what the homework will be. 3 sides, they'll give you some of them. Okay, 3 sides and 3 angles, and that's homework 11. You may not want to turn off your tape machine, because I've got more to come in this episode. Okay? Okay, my hope is that you've done your homework, okay, and you know everything there is to know about the law of sines, which isn't too bad, okay, and you think you know it all. Well, you don't know nothing. Okay, let me show you. Okay, we're gonna talk today now about the law of cosines. Whole different deal. Okay, why would I need that? Well, let's look. Let's look why you'd need that. Let's look back at the law of sines first. Do a little review, and hopefully I can show you why we need that. Okay, let's look. Considering a problem that we've seen before here, the law of sines. Okay, remember your old buddy, the law of sines, said if I wanted to find this side, for instance, I know it's a side because it's a lowercase letter, as long as I had a matching pair being a side opposite an angle, a matching pair, okay, I could go the side over the sine of the angle opposite it equals, and I have my matching pair here, 4.56 over the sine of 43. And I could solve for B. I'll multiply both sides by sine of 57. I got to cancel, I guess. And I'd have B by itself, and I'm cool as a mule. Okay, I could put that into my calculator, and I could actually get an answer for this side B. Okay, other things you could do with the sine. Okay, let's look at another one. Suppose I asked you to find this side. Well, remember, there's a little bit more to it in this case, is that I can't find a side unless I at least have the angle opposite it. Okay, but I can find that angle if I know the other 2 angles in the triangle. Remember, you can subtract it from 180, subtract the other 2 from 180, and get that angle, which in this case was 80 degrees. Okay, well, now I can find C, lowercase c, I mean. Okay, be c over the sine of 80, and I'd pick the only matching pair that I know at this point, 4.56 over the sine of 43. Okay? Solving for c, who's keeping c from being by himself? Oh, the sine of 80. We'll multiply. We'll get rid of him soon. Cancel. And I'll get c equals all this stuff, okay, which I can put into the calculator and figure out, 6.58, okay? Okay, well, you know, I'm finding things like there's no tomorrow. I'm finding angles, I'm finding sides. I don't even need a right triangle. I'm on fire, okay? You think you know it? You don't know nothing. Because consider this problem, okay? Okay, we're going to use the law of sines. Let's see, what do we want to find here? I'm going to do 18 over the sine of A, but I don't know what A is. Let's see, equals 25 over the sine of B, but I don't know what that is. Uh-oh. 12 over the sine of C. Uh-oh. I don't have any angles in this case. Don't! Well, I don't know any of the angles, so I can't use the law of sines. And I can't use anything else because it's not a right triangle. Okay? In this instance, what I would say, we don't have any matched unknowns. When I mean matched, we don't have a side. I only need one side and the angle opposite it. I need one match, but I don't have a match, okay? In fact, we have a name for this situation. It's called SSS, okay? Side, side, side. Okay, as you can see, that's all you have. You don't have any angles. Side, side, side. Okay? This is not going to be solvable by the law of sines because we don't have a match. Okay? There's another situation like this. Now, let's take a look at this bad boy. Okay? If I wanted to find something. Okay? It looks like I got an angle here. That's good. Okay, where I didn't have one before. Okay, I could go 32 over the sine of A, but I don't know A. Okay, maybe I could try this B. I could do B over the sine of 15, but I don't know B. Dang nabbit. Or C over the sine of, but I know the side of C, but I don't know the angle. So here again, I don't have any matching pairs. Okay, I have an angle, but I don't have any matching pairs. Dag nabbit, I have to have what I mean is a matching pair to use the law of sines. A matching pair, once again, being an angle and the side opposite the angle. Okay? We're going to put I'm going to give you a name for this situation. There's only two situations. This situation is called SAS. You know why it's called SAS? Because you can see where you got side and an angle and a side. Okay? And if you have that situation, as you can see, you're not going to have any matching pairs. Okay? These two situations, SSS, or side, 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 and side angle side, okay, call for the big guns. Okay? The big guns, not easy, so put your thinking caps on. But the big guns, we need the law of cosines. Okay? So I'll have to show you the law of cosines, and I'll have to derive it for you. You won't have to derive it, but we're going to use the law of cosines. Let me see if I can derive it for you. Okay, let's put a triangle at the origin of the graph here. Okay, we're going to put it on a graph. I smell X and Y coming here. Okay, let's put it on the graph, and and I want you to consider something. That is the point 0, 0. Here's the point A, 0. What do you mean A, 0? This is side A, lowercase a, so that's an A. Okay, and this is the point we're going to call for right now, temporarily, X, Y. Okay, it's just a X, Y. Okay, now consider this. Well, bring in the right triangle. Okay, look at this triangle right here. This triangle right here. This side being X, because that's the point XY, and this side being Y. Okay, no big deal. It's not like you're limiting yourself to anything. It's X and Y. Okay, you might say well, X is negative. Oh, you got me. Okay, it's in the negative. But in this case, okay, but distance can never be negative, so it really doesn't matter. Okay, we'll just call it X, or whatever the X value is. Okay. Now, the cosine of C. What would the cosine of C be? The C being this angle right here. Okay? Isn't it going to be adjacent over hypotenuse, X, and B is the hypotenuse. So that would be the cosine of C, son of a gun. Okay? Now I'm going to solve for x. Okay, I'm going to crossing out the b here. X is going to be b cosine c. Relax, okay, but that's what x is. Okay, we could say that's another way to say x. Okay, and couldn't we say, what could we say about the sine of c? Now this being angle c right here would be the opposite over the hypotenuse. The opposite over the hypotenuse. The opposite in this triangle is y, the distance y, and the hypotenuse once again is b. Okay, so the sine of c is y over b. Let's solve for y. Who's keeping y from being alone? The b. Okay, multiply both sides by b, and y is b sine c. Now once again, x is b cosine c, and y is b sine c. Ooh, what's he going to do now? Well, I want to show you. If that's the case, couldn't we say instead of xy, now look what just happened, let's do it again. Instead of xy, because x is b cosine c, and y is b sine c, which I showed you, okay? Believe me, I didn't pull that out of my hat. Instead of writing this point as xy, I'm going to write it as what x is and what y is. Okay? Now, why would I do that? Okay? Hang with me here. Why would I do that? Well, now I'm going to bring in a big triangle. Come on in. Come on. Okay. I got a big triangle, and what I want to do is use the Pythagorean theorem. Okay? I'm going to set up something with the Pythagorean theorem. What would this side be? How tall is that bad boy? Well, that would be the y-coordinate of this point. How tall is it? Well, the y-coordinate, as we solved for, is b sine c. Okay, so that's how tall. As crazy as that is, that's what that would be. And how long would this be? Come on in. Come on in. Don't be shy. Tell us, what would that be? Well, that would be, that's tough. That would be the x-coordinate of this side, which is a, subtract the x-coordinate of this side, which, as we just showed, is b cosine c. So we subtract one from the other. And don't worry about which one's bigger, which one's smaller, because distance can never be negative, so that's not going to be a problem. So we subtract the two. Okay, now let's set this up with the Pythagorean theorem. Leg squared plus leg squared equals, in this case, c squared. Okay? So c squared equals this leg squared plus the bottom leg squared. Okay? I'm going to multiply all that garbage out and hopefully come up with a theorem. Okay? C squared equals multiplying that plus squaring this. Okay, now I got some multiplication to do here. Well, it's easy here. Just multiply those two. I get b squared and sine squared c. Okay, not a big deal. Multiply this times this, I get a squared. Multiply a times this, I get minus ab cosine c. Now I'm done with a. Now u. This times this, I get another minus ab cosine c. I switched them on you. Okay, and then the last two terms, this times this, a negative times a negative will be a plus b squared cosine squared c. Okay, let's see if we can make some sense of all this stuff. Okay, well, c squared, I'm going to take this and bring it down here. I'm going to bring this here. No, I'm going to bring this guy over here. Why do I like those together? We'll see in a second. Okay, then the a squared. And I put these two together. Since they're both the same, I got one of them and one of them, I got two of them. Okay? I'm going to factor out a b squared out of these two terms. Okay, why did I want to do that? You would marry c squared plus cosine squared. I want to show you why. Remember the Pythagorean identity? Okay? And I'll just bring those two down. Well, b squared times 1. Isn't sine squared of anything plus cosine squared of something is 1. So we can get rid of that altogether. Okay, let's bring the other two down. Okay, and guess what? If I switch the b squared with the a squared, this nightmare, which you'll never have to do, don't worry about it, this nightmare is called the law of cosines. Okay, now what good is that? Just note for right now that it didn't come from my hat. Okay, that it really, we really did derive it. Okay, how could we use the law of cosines? And that's only the law of cosines for c squared. What in an oblique triangle, c, a, and b, really you can, if you rotate the triangle, you can make it anything you want. So if we get the idea of the law of cosines, for instance, this is the one we derived. if that's the one for c squared, where it's the other two sides squared, the sum of a squared b squared, minus 2, that's part of the formula, times the other two sides, times the cosine of the angle opposite this side. Okay, what's the a squared version of this? Well, same thing. What's similar about it is a squared will then equal the other two sides squared minus 2, the other two sides multiplied, and the cosine of the angle opposite it. Let's do it for b squared. The other two sides squared, the sum of the other two sides, minus 2, the other two sides multiplied, cosine of the angle opposite it. Okay, so it's the same. It'll work for any of these is the point. Okay, well, why do I want to know this? Well, in this example, this is going to be very useful in, for instance, SAS. I'll have a side, an angle, and a side, and I can solve for the other side. Okay, well, let's do it. Okay, and this is the part you will have to do for homework, okay? Find the missing side. Okay, I want to find this side, okay? So I'm going to use, this is an SAS situation, so I can't use the law of sines. I'm going to use the sign, the part of the law of sines that's the b squared one, okay? Because I know A, I know C, and I know the cosine of B, side, angle, side, okay? Let's fill the numbers in. In this case, A is 32, C, lowercase c, is 24, and I put the 2 in here, and the cosine of B, which I know is 150. All the numbers are fit, okay? Do a little calculation. I'll show you a little bit of it. 32 squared is that, 24 squared is that. Do a little bit of multiplication, 2, 32, and 24, and get that. And continuing on, all this added up, I promise, all this calculated is 2249. Okay, I just put it into the calculator. Now, that's b squared. 2249 is b squared. Taking the square root, I can find that b is, right on the head, that's ridiculous. What a coincidence. 47. That's too nice. But I could find, using the law of cosine. I couldn't have found that using the law of sine. Okay? And that's my answer in this case. Let's do about 10 more. Okay? Okay, what if I have to find an angle? Remember angle, 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 side, 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 I couldn't do it. Okay, this time we're going to try and find an angle. Okay? That's the side, side, side one. And once again, I'm going to use the b squared. Okay, because I smell b, because that's the angle I'm looking for. Okay? Well, the only numbers I can put in here are the ones I know. B is 25, and I know A and C. I'll put those in, A being 18, and C being 12, the side opposite angle C. Okay, and I'll put those 12 and 18 in, but I don't know the angle B. And that's the only thing that's missing here. Okay? Well, let's solve this equation. This is just a little algebra, multiplying everything. 18 squared and 12 squared. Do a little multiplication for you there. 2 times 18 times 12. I know you all knew it was 432 right away. Okay, let's see. Let's subtract these from both sides, because I'm going to start getting cosine of b by itself. Okay, subtract that from both sides, and I'll get 157 is the minus 432 cosine b. Now, I got to get cosine b by itself, because I'm trying to find b. Okay, so let's, who's the troublemaker? Negative 432. Let's divide by negative 432. Okay, and dividing both sides by negative 432, this side I get this figure, and the other side I get cosine of b. Now, I don't want to know cosine of b. I don't want to know b. Okay? Remember your old buddy, the inverse cosine button. If you know the cosine of an angle, you can find the angle. Okay? So we'll uncos that boy. Okay? Using the uncosine, or the inverse cosine of negative 0.3634, we found out from the calculator that b is exactly 111.31. You love that. Okay? Couldn't have done it any other way. Okay? Let's look at a couple more examples. Okay, let's see. Let's solve. When I say solve the triangle, I want you to find everything. So we'll just pick one. Pick something we don't know. In this case, we know the three sides, so we don't know an angle. Let's try and solve this angle. Okay, I smell b. Okay, so let's use the version of b squared. Putting in the numbers, b being 13.4, lowercase b. Why? Just stop for a second and see. That's the side opposite b. I want to make sure that you know that's b. Okay, and what would a be? It's the side opposite a, 6.7, and c would be the side opposite that. Okay, so these are how I'm filling these in. Okay, and I'm filling them into this part of the equation as well. Okay, let's do all this multiplication. I'll do it for you. You paid for me. I'll do it. Okay. 6.7 squared is that. 16.6 squared is that. And then get all this multiplication. 2 and this will give me this nightmare. Okay? Okay? Now what I'm going to do is subtract all of this from one side, from both sides. Okay? And I'm going to be left with negative 222.44 cosine of b. I just took these two numbers from here and took it from this number and ended up with a negative. Now let's divide. We're going to solve for cosine of b, so I'll divide by what's keeping him from being alone. And that'll cancel out. And what will I get on this side? A teeny-weeny number. And that'll be the cosine of b. Well, how do I find b? Well, take the inverse cosine. Okay? And the calculator will tell you that b is 50.7 degrees. Okay, looking good. We're rolling. Okay, well, b is 50.7 degrees. Now let's find the rest of these things. Let's find this bad boy. Once again, I could use the law of cosines. Okay, and in this, since I'm looking for a, I'm going to use the a squared version. Okay, a 6.7, putting in b and putting in c into the theorem, okay, and multiplying all this stuff out. Let's see. This is 44.89. What's this? That's 179.56. Get your calculator. Type fast. Okay, this is 16.6 squared is that. And then let's figure out what all that multiplied is that. Okay? Now I want to know, I've got to start getting cosine of a by itself. Okay? We'll put these two together and get this number. Okay, and bring him down. Now I'm going to subtract this from both sides, 455.12 from both sides. And I'll get, on this side, negative 410.23. That'll cancel. And on this side, I'll just be left with what's there. Okay? Now let's go to another page here. Okay, so that's what I'm left with so far. Okay, let's see. What's keeping this from being by itself, this troublemaker? So he's multiplying, so let's divide. Okay, and I'll divide this side. And on the other side, I guess it cancels, and I get cosine of a. So I can figure out what a is using my inverse cosine button. Okay, inverse cosine of what? Inverse cosine of 0.9221. And it's 22.7 degrees. Okay, now I want you to consider something. Or, we did that took a long time, okay? Another way of doing that is that once I have a pair, I can use the law of sines. And I want you to make it easy on yourself, okay? So, once you have a match, what I mean by a match is A and A, B and B. What do I mean by A and A? I mean angle A and the side opposite, little a, angle B and the side opposite, little b. Once you have a match, okay, it's probably going to be way useful for you to use not the law of cosines, but the law of sines. Okay, to me that's easier. Now you do it however you want. You can slap yourself in the face if you want to too. Okay, but I think it's easier to use the law of sines. That's only once you have a match. Okay, other things that you may want to use is the fact that the sum of the triangle angles is 180. Okay, once you have two angles, you're on fire. Okay, so another way to do the second part of this problem, once I had figured out that this angle is 50.7, you know what I would do? I would use the law of sines, okay, because I have a match here. You see I have a match. So if I wanted to find this angle, which we did last time, we better get the same answer. Huh? I'll use 13.4, switched it on you, 13.4 over the sine of 50.7 is the same as 6.7 over the sine of my angle. Okay, remember how we solved that? We're trying to get this sine of x by itself. I multiplied both sides. I just manipulated it a little bit. Let's see, I'm going to multiply both sides by sine of x to get it over here. And that'll cancel. Okay, let's see. Now I'm going to divide by him. And that'll cancel. Okay. and I'll get the sine of A, or the number I want, is 0.3857. You better get to know how to use your inverse sine button. Okay? And to me, that's way faster, and it's easier to memorize the law of sine. Okay? And I get an answer of 22.7, which is what I got before, thank goodness. Okay? Okay, and you know what? Once I know that, you're not going to use the law of cosines or the law of sines or the law of curly fine. Once you know two of the angles, how are you going to find this other angle? Don't make it hard on yourself. Okay? You're going to use your old buddy subtracting the 2 from 180. Okay? So make it easy. In this case, C is 106.6 degrees. Okay? So make it easy on yourself if you can once you know a pair or once you know two angles. Okay? Let's do one more example, just to the point where you're truly sick of it. Okay? Let's see, what are we going to find in this one? I want to find B. Now, do I need to use the law of cosines or the law of sines in this case? Well, I don't see that I have a matching pair. Okay, as I look. B, there's got that angle. I don't have a matching pair. So what am I going to have to use at the beginning? I'm going to have to use the law of cosines. Can't use the law of sines. Okay, so you're stuck. Okay, so let's, because I don't know, and I can't figure that angle out because I need to know at least two angles to figure that. So I can't do that either. So I hate to do it, but I have to use the law of cosines. Okay? Can't do it. Okay? So let's try it. Let's try and find side B. Okay? B squared, putting in the various numbers into the law of cosines. B will be itself, because you don't know it. A will be 23.78. It's the side opposite A. C will be 25.74. Let's put him in there. And then we'll put them into the other two. Okay? And I know what angle B is. Okay? This is the SAS Billy. Okay? That squared is this number. This squared is this number. Don't expect you to calculate quite that fast. I'll do it for you. This multiplication is this. Okay, now let's see. I'm going to put all this together and get a number. Okay, I'm figuring your calculator can do that for you. But that's not B, that's B squared. So what do I have to do to both sides? Well, I have to take the square root. And the square root of 8, you can use your calculator to do that as well. It's 29.38. Okay? Well, now I know what B is. Come on in, baby. Hi, Mom. Okay. Well, now that I know what B is, and perhaps I want to find the other two. I want to find angle A. Well, let's not make it hard. Let's use this time, since I have a pair, let's use the law of sines. Okay? In this case, lowercase b, 29.38, over the sine of b, 72.66, is, we're trying to find a, the lowercase a over the sine of a. Okay? Let's solve for this. I'm going to cancel. Okay, let's get rid of these guys. I'm going to multiply by 72.66. Who else is troublemaker? We got to get rid of this 29.38. Let's divide by him. Okay, and apparently the sine of A is all that stuff. Now, how do you find A again? Your old buddy. Once you know the sine of it, you can find A using the inverse sine. Okay? Just a little bit of algebra here. Nothing new. Okay? And we found A to be 50.58. Okay? Well, let's put that bad boy in. 50.58. Now, what do they want you to find now? Now, we're 5/6 of the way there. Okay, we have 5 of the thing. 1, 2, 3, 4, 5. We want to find this. What's the easiest way? Let's always use the easiest way. What's the easiest way to find that angle? Okay, you could use the law of sines. You could use the law of cosines, but I think once I have two angles, I'm going to use the fact that the three angles have to add up to 180, and let's do some subtraction. Okay, 180 minus these two, I mean, let's make it easy on ourselves, is 56.76. Okay, and we found everything, and that's called solving the triangle, finding everything. Okay, oh, that's enough. There's the whistle. Okay, listen, at this point, I want you to do homework 12. Okay, and basically you're going to be solving the triangles. You're certainly allowed, you know, sometimes you'll be forced to use the law of cosines, okay? But once you find a matching pair, or once you find two angles, okay, I want you to make it easy on you. I'm not going to take off, okay, if you do it a different way, if you use the law of cosines all the time, okay? But that's my suggestion to you. And if you look on the internet page, that's the way I did it, okay? I did it the easiest possible way. And you certainly want to do that on a test because the test is timed. Okay? So let's see. At this point, you're going to do the review assignment, which is homework 13 as well. Okay? You'll really want to do that. And then you'll go take the final exam. Go to the assessment center and take the final exam. So it's been fun, and maybe we'll see you in pre-calc. Have a good one.